Alright, I think I'm gonna spend 1 hour here today. I'm not streaming because I'm working on the project. I think I'm not gonna stream regularly until the date for the Buildspace Nights and Weekends stuff is over, which is by 6th of August of next month. And I still have a lot of stuff to do. I pretty much haven't displayed the data. I wasn't able to display the data. And it has been, I would say, as hard as I thought it would be, but it's taking me longer than I thought it should do each thing because there's a lot of roadblocks on the way that I'm encountering, which is a good thing because I'm learning a lot and I already kind of expected that. But I'm not sure if I'm gonna be able to have anything by demo day, by the end of the nights and weekends stuff. So that's my main priority, is to have at least something to show. I think I'm very close to getting the data, but I'm having issues because I think the size of the data from the back end to the front end is too big, and I'm getting some errors and I have to figure out. So I've been studying get server props from Next.js and different methods of, I'm thinking about different ways that I can organize the data in the backend. Not organize, but filter the data instead of fetching everything at once. I'm debating whether or not which strategy is the best because I have no idea. I think it makes more sense to get all the data at once, get all the data in parts, depending on what page I'm at, and because you're only able to display at most 100, I think, or 200 in a page. Obviously, you can display the whole data, but then it gets really slow. That's the problem. So there's this trade-off between fetching everything and then being really slow, and fetching just small amounts, but then I'm not sure about, because then we have to handle the logic for all the other pages. And I'm debating in my mind which way to go with, because I'm not sure which one is the best practice. And I think I'm going to spend 1 hour here. I've looked at Etherscan a couple of times to see how they organize their stuff. And it seems like they do it like this, and then each one has an option, has paginations, 4 options of how many transactions and blocks to display. And there's also a lot of stuff here. It's probably really hard to build all of these things. And I definitely won't be able to have time to do any of this by the end, but hopefully I can at least build these cards like this. Obviously, I'm not gonna do something like they do exactly. I'm gonna do something different. And I have my ideas of what I want to explore, but yeah. And to be honest, I thought by this point I would be able to study the methods already, but all this stuff took longer than I thought. Because that's the main interest I have in this project, is just, like I said many times, analyzing the data and making conclusions about it, and not all the other stuff about authentication and building the website. But it's good that I think at the end of this stuff, I'm gonna have, at the end of the nights and weekends, I'm gonna have all of this stuff handled, and then from that point on, I can focus on analyzing the data and studying different methods. But there's also a lot of other stuff that is gonna be hard as well after, because the more data you have, then you need to start integrating data lakes and using Kafka. And I think I'm gonna try to incorporate Redis already before nights and weekends, which is a backend layer that makes things faster. So you have Django, then Redis works kind of like a bridge between Django and the front end. Just if you imagine like a funnel, you have a large data set, then from the large data set goes through Django as it scales more, and then from Django it passes through Redis, and Redis displays on the front end, so it's fast. And so you can be fast and have a lot of data simultaneously. But that's how they do it here. They have the pagination, and I have. But I'm not sure if the way that they're doing this is by getting all the data up front and then just changing the pages on the front end, or if they are getting the data for each page on the back end. So they do the query on the back end and then send the data. I think that makes more sense to me. I think that's the approach I'm gonna try to implement. Because if you get all the data at once, then I think it's too slow, the more data you have. And it's also a lot slower than I thought it would be, the way that I'm populating the data now. And that's what I'm gonna do today, because I'm thinking about getting the data and putting on CSV files, but then creating some kind of data flow where after the CSV reaches a certain size, I get all of the data from the CSV and pass it on through the database. And from this video I was seeing, seems like there is better ways to put all the data from CSV, from data frames into Django. And I think that might be faster. But then I was trying to see the data here that I have, but it's too big and it takes too much time to open this. And I think it's because of this method here, read CSV, because I tried printing before and it wasn't showing. The smallest one I have took a lot of time to see, and the other ones it didn't even open. I didn't wait long enough, but it took more than 1-2 hours, and then I just, because it made my computer slower as well, and that's obviously a big issue. But there must be a way that someone else probably figured this out, because I'm probably not the first one to deal with large data frames. Or I'm not supposed to do things with data frames and pass them into another method, but it seems like the SQL is even slower to populate, so I'm not sure. Yeah, this one, it didn't even open, and then I think I tried to open this one, and it worked, but it took a very long time. And I was trying to do this while I was trying to build the script to populate databases. So I think after I'm able to figure this out on how to get the data in the front end, figure out I think the problem that I'm having is that I'm getting too much data at once, because it was giving me a buffer overflow, I think, or something like that. I'm not really sure. And I think probably after I'm able to figure that out, I will be able to display the data into the front end from the back end. So I think I'm pretty close, and the rest is already done. And then after I do that, then I'm going to style the pages, and I'm going to create another page, which is going to be, these simulations here. I'm going to put several different cards, I think, which I'm going to do with a component. And then each card is going to be a link to a graph which I'm gonna do with the network-x library, the same way that I did it in the past. And I think I'm gonna do that because it's easy to, it's probably gonna be easy to do, given that I already done in the past, and then I can display it and have something to show more. I think it will be cool to have a bunch of different graphs that show relationships between different things that I can see here. But the only problem with that is figuring out how to make it faster to analyze the data frames, because I'm gonna build the graph of the data frames. And yeah, I'm just gonna build the graphs and put the graphs in the project, but later on I might try to figure out a way to integrate the graph creation with the website. And I think I might do that on stream, but I'm not really sure. Because I'm not sure how much I want to show of this project. I think the way that I'm going to divide it is going to be, I'm going to study stuff that I need on stream, and then I'm going to work on the project off stream, and then I'm going to talk about things that I have already done. I think that's probably the best way to go about it. Yeah, so for optimizing the data frame, I think I remember watching videos about it in the past. Then I researched, and it seems like this is a library that is a lot faster than pandas. So I'm gonna see. I'm gonna try to use this library to do the stuff with the data frames that I have. And I've been learning a lot as well about everything pretty much. I think now I pretty much know Django. I don't know it very well, but at least I know pretty much everything you can do from authentication standpoint and the basic stuff. I just don't know the more complex things. But I had to watch a bunch of different videos all the time as I was building, so it was really helpful to learn it. $146 million rows, 12 gigabytes. How many do I have here? Oh, I had to split as well the data frames. I deleted some of these and passed to the other hard drive because it was getting too big. I'm pretty sure this is 37, 36, 36 gigabytes. But I don't think this has, maybe it has hundreds of millions of rows. That's probably why it's very slow as well. Oh, the other thing that I'm thinking about doing is building my own node eventually. And I think I'm gonna do that, but it's gonna be after nights and weekends is over. I'm not gonna have enough time to do that until then. But hopefully, yeah, I'm not really sure how fast it's gonna be to get the data and manipulate the data with my own node. It would make sense to me that somehow it's faster, but I'm not sure if that's the case. And then I will see if it's possible to use my own node to populate the website instead of using the Alchemy API, the RPC API. How is that possible? I don't understand. Why is pandas so slow? And this is so fast. Yeah, obviously has to do something with the algorithms, but it's pretty crazy that it's possible to have this drastic difference in efficiency. Well, the other problem is, yeah, the biggest issue is going to be the size of the graph. And because I remember even smaller graphs, like they had less than 1 million rows, were really slow to load. So I think that's going to be a big problem if I create graphs of the... But I remember doing a graph from the data frames. But it was probably with a smaller portion. And so I think it's probably... That's probably how I'm going to end up doing, which is find the biggest amount that is not really... that doesn't get really slow, and then chunk it out. And then just put time frames. I think that's a good idea. But maybe there is a way as well. I think I'm gonna study. I think I'm just gonna do it like this initially, so I have something by demo day, so I can create something on the simulations thing. Because I'm pretty sure I'm not gonna have time to figure out these links here by then. Because I will have to study the methods, which I'm probably gonna do on stream. But I want to have at least this page, which I think is going to be possible based on how close I think I am, which might be off as well, because I might encounter problems that I don't know about yet. And then I would like to have these simulations as well. Simulations page. So I think I'm going to do it with Network X, and because it's what I know and it's going to be easier. But then after demo day, I think I'm going to study and research ways to see if there's a better way to create graphs that allow me to display more data than, which I'm pretty sure, not really sure, but I think there might be different ways. It's obviously better if I can display the whole data instead of having to chunk and different amounts. I'm gonna need something from Visual Studio, from C++. That's probably the reason why it's faster. I always forget that this thing is different. I think I'm gonna try to do something similar to this for the main page there until the demo day, but with less buttons here. That's a lot of work, but I think I understand how they did this. It's pretty much just creating different components. And then there's something about pagination as well on Next.js that might be good to use, but I'm not sure if I'm gonna use it because it's kind of confusing. And I think it's there's a difference between static props and server props, and the pagination is for static props. And in my case, it doesn't work because I'm getting the data from the server, but I'm not really sure. Because here, yeah, it looks like they are probably using the pagination stuff. If I had to guess. And just addresses and then the address. Or they have it, yeah. Actually, it's probably they have a table, and that table has a view which has all the addresses, and then they have a slug here to populate this. So based on which address it is, you put here, and then this is the main view for the address. It's probably what they were doing. Yeah, but whatever. Oh, I just forgot that I had the volume down for the video. Oh, whatever. But isn't that gonna affect the library? The binaries are not installed. Maybe you should search for how to install. I think I'm gonna keep this here. In case the other methods don't work, I can try this one. And the problem if I install with Conda is that I already have the virtual environment here. I don't think I can do both. Either use Conda or the VM. See if I can watch more videos on this. I've also been practicing typing, and I've improved a lot from last time. See if my record has been 110. No, which is lower than I was before, but it's getting close, sure. And it's much easier to type this way, but it's a little bit more annoying to learn, I think. The mistakes are making me very slow. It's still much better than before.
Hello, my name is Krishna and welcome to my YouTube channel. So today in this particular video, we are going to discuss about this Vaex library. Before going ahead with respect to this particular video, guys, I want to announce iNeuron is actually starting a new batch on June 6th with respect to machine learning and deep learning. They're also going to cover PySpark and Spark. Along with that, they're also providing you internships. So it is basically a 5 months plus 3 months program. 5 months is basically the course. 3 months is basically the internship opportunity that you'll be getting. So please make sure that you join that particular course because it's completely affordable, guys. For 8 months, you just have to pay 3,540 rupees INR because they have already started a lot of community things and probably in the future again they're going to collaborate and start more community like statistics and other courses like big data and all. So please do support them. They're working really, really well. I think we all should support iNeuron as a team because they're working really, really hard. So this is an amazing library which will actually help you to explore huge data set, to analyze huge data set, and it's pretty much similar to pandas. So if you have actually worked with pandas, one of the disadvantages with respect to pandas, right, it's pretty much slow, right? And if you have a huge data, that may take a lot of time to actually, to execute some of the programs over there with respect to the pandas library. So considering this, we'll try to discuss about Vaex. This Vaex library is very, very helpful, and there is also one Dask library also, and probably in the next video, I'll be also uploading a video regarding that, and then we'll try to compare Dask and Vaex. Okay, so both these particular libraries we'll try to compare, but remember, both those libraries will be actually helpful for you to work with big tabular data sets. So what is Vaex? So Vaex is a high-performance Python library for lazy out-of-code data frames similar to pandas to visualize and explore big tabular data sets. It calculates statistics such as mean, sum, count, standard deviation, etc. on n-dimensional grid for more than billion sample per rows per second. So this is a huge.
I'm also using this extension here that I found out that I didn't even think about before, which allows you to increase the playback speed more than 2x on YouTube.
Is done using histogram, density plots, 3D, volume
It's really good.
interactive exploration of big data. Vaex uses memory mapping, zero memory copy policy, and lazy computation. So this is pretty much important. Lazy computation is a technique which is already being implemented in C# to make it faster. So everything will not get loaded then and then. Only when you're calling some internal function, then only that particular value will be actually loaded. So lazy computation is one of the things, and why it is basically getting used for best performance. So no memory is wasted. So what I'm going to do is that first of all, let's create some huge data set. And first of all, before going that, guys, we have to install this. So go to your Anaconda prompt, and then I'm just going to activate my environment which I'm actually working on. And in order to install it, you just go and see what is the command. So I am inside this py.org inside that Vaex. You can see that the command that is used is basically pip install Vaex. So I'm just going to write pip install Vaex. So I'm just going to execute it. I've already installed it, guys, so it is already showing you requirement already satisfied. But if you did not install it, please make sure that you use this command and automatically get installed. So this is done. Then what I'm going to do is that we will try to create a huge data set. Over here, just imagine how many rows are here. So 1, 10, 100, 1,000, 10,000, lakh, 10 lakhs. So I'm just going to consider 10 lakh, records. And what I'm going to do is that, so this is basically somewhere around 1 million records, and number of features that I'm going to take is 50. And here I've imported Vaex, I've imported pandas, I've imported NumPy. Okay. Now inside this, I'm creating a data set where I'm saying that pd.dataframe, and here I've written np.random.random. I'm saying that you have to initialize values between 0 to 100. How much? We have actually given the size over here. The size is basically number of rows and number of columns. So that basically means we are taking 1 million records and 500 columns, and randomly all the numbers will be initialized between 0 to 100. Okay. And apart from that, I also said that okay, you also have to give a column name, and this is the for loop. Like I'm saying that for I in range in number of columns. So whatever number of columns it is coming over there, right? Over here I've taken 500 columns, so it will be ranging from 1 to 500, 0 to 499. Okay. Then I'm saying that put the column name as column that particular number. So for the 0 iteration, the 0 column, this value is 0, right? So as soon as I execute this, guys, you'll be able to see that we will be creating this data set, and probably this is having 1 million records, okay, and it is having 500 features. Now this is a huge data set, and initially I've actually created this in the form of data frame. Okay. Now if I try to do any kind of pre-processing in this, guys, it is going to take a whole lot of time. Just write by yourself, the kernel will be getting stuck, your Jupyter notebook will be hanging completely. So don't do any kind of pre-processing, but I'll just show you how I can actually use this, considering Vaex as my library, how I'll be able to perform much more better than pandas, perform some kind of analysis and say that how it performs much more better than pandas itself. So considering the data set, I want to see that how much memory it is going to use. So you can write d.info. Memory underscore usage is equal to d. Okay? And remember guys, all the references have been taken over here from here. You can see everything over here, so you can actually check it out and you can basically execute all these things, right? So df.info memory usage is equal to d. If I do this, you'll be able to see that the memory usage is somewhere around 1.9 GB. So that is a huge size, you know. And suppose if you're having some less RAM, somewhere around 4 GB, probably this will probably take a lot of time to actually store or create this particular data set, right? Now, the next step what I'm doing is that whatever data set is actually created, I'm actually going to create my CSV file. So I'm saying that whatever data frame is there, I'm just convert that into a CSV file and file underscore path index is equal to false. Okay, so when I do this, automatically the CSV file will be getting created. And remember the size will be somewhere around this. I've already executed this, guys. If you have somewhere around 8 GB RAM or 4 GB RAM, it will probably take and it depends on your system, guys, how fast you'll be able to create this CSV file, because understand it depends on the number of records that I'm actually using. And I have a powerful system, it hardly took me within 30 seconds to execute this particular code. And if I go and show you in this particular path, you'll be able to see my final data underscore data.csv file that is already been created. Okay, so that's created. Now remember, if I want to use this particular library, what I have to do is that I will try to convert this CSV file into an SDF file. Now what is this SDF file? Let me just go over this SDF file. Okay, so I'm just going to search this in Wikipedia. It says that hierarchical data format is a set of file formats to design, to store and organize large amount of data. Now when I convert that into an SDF file, it will be formatted and stored. The data will be formatted and stored in such a way that it will be easily will be able to extract it, will be able to analyze it, will be able to apply different kinds of operations. So this particular library, when I'm talking about this library that we're going to use, right? We have to make sure that we convert this CSV file into an SDF file. Now in order to create it, I have a function called from underscore CSV. You can see over here, I'll shift tab. Here it says that from underscore CSV, you can see everything. Read the CSV file as data frame and optionally convert to an SDF file. Pretty much simple, right? So the first parameter is basically my file path. It is nothing but final underscore data.csv. And saying convert is equal to, and I'm going to say chunk size. Now when you give this, when you execute it, it will probably take again some more time, and you'll be able to see that the final data.csv will get converted into final underscore data.csv.sdf file. Okay, so this is the format that is always required when you're using Vaex. So make sure that, and remember guys, when you're working in AWS, when you're working with some kind of big data, you know, in AWS also there is something called S3 bucket. Although SDF file will actually get stored in the S3 bucket, and you can call that S3 that particular file from the S3 bucket, and you can actually retrieve it over here. Now see this, as soon as I see that what is the type of this, then it is basically saying that it is SDF file memory map. Now let's read that SDF file using this Vaex library. So what I have to do is that we just use this Vaex.open final underscore data.csv.sdf file. This is the file name. So as soon as I execute this, and remember, as soon as I say this.head, you can see that I'll execute this in front of you. How fast now to get executed? Remember, if I make this final underscore data.csv and try to read it with the help of pandas, it will take a whole lot of time. Now remember, if I use .head, it actually shows me the top 10 records. Now you can see that how quickly it is happening, right? And remember, if I see the type of Vaex underscore df, right? Vaex underscore df, right? Let me just see the type. It is basically saying that it is SDF file memory map. Perfect. Now this is the head. Head basically shows the first 10 records. Now let's see some of the expression systems, some of the mathematical functions that I apply over here. How quickly it will be doing. And remember, guys, we have 1 million records. That's a huge size, right? So considering this, let's see how does the expression system work. Don't waste memory or time with feature engineering. We lazily transform your data when needed. So this is what Vaex does. Okay? It uses lazy techniques to transform data whenever it is required. Now in this particular operation, remember the whole data set is present over here. And inside this you have columns like column 0, column 1, 2, 3, 4 like that, right? And suppose I'm creating a division column, and it says that this one thing basically specifies that column 1 is getting divided by column 3. Okay, so when I do this particular division, you'll be able to see that how quickly it has happened, right? And if I execute and show you this is how quickly. If I try to see the operation of the time, let me just see what I'm going to do. I'm just going to use the time library over here, and let me just execute it. You can see 251 milliseconds to actually do this computation when you have 1 million records. That is amazing, right? So if I just want to see this quickly, it is also displaying things, right? This is one of the properties called expression system. There is something called out of code data frame, right? We can actually do filtering, we can evaluate expression. This is just not with respect to division. You can do multiplication, you can do different kinds of operations as you want. Let me just try multiplication over here, and I'm just going to say that okay, this is my column of multiplication. Okay, so if I execute this, let's see, 0 nanoseconds, amazing, right? Now if I try to see this particular column, see this is how it is very fast. Okay, so you can try different operations definitely. Okay, the second thing is out of code data frame. Here we can do filtering, evaluating expressions, and this will not make or it will not basically will not make any memories. So you can see that what it is saying over here, filtering and evaluating expression will not waste memory by making copies. So the data copies is not made over here. Okay, I'll just show you what kind of operation I'm talking about. The data is kept untouched on disk and will be streamed only when needed. Delay the time before you need a cluster. Okay, now let's see an example. Okay, let's see a quick example. Okay, over here, what I'm doing is that I'll just execute in a different tab. Okay, so I'm just saying that inside this particular data frame, inside the column 2, wherever. Okay, so I have my column 2. I just want all the records which is having greater than 70 value. Okay, so that is what I'm actually doing over here as a filter operation. So that is what this whole expression basically means. Now if I try to execute this, see how quickly it happens. Okay, hardly it will be taking less time and all the records are there. You can see that 289,472 records are greater than 70 in column 2, right? So it is actually displaying all the records, but it is very fast. If you try to do this with the help of data frames, trust me, it is going to take a huge amount of time. Okay, so make sure that you actually note this down. You know how beautiful it is. So let me just say, and why it is not taking much time, because here it will not make a memory copy. Whereas in pandas, when you're using pandas, it makes an extra copy. Okay, so I'm just going to execute this. Okay, then there are a lot of inbuilt functions inside this. You know, when I'm making this particular condition after filtering, you know, you have mean, you have median, anything you have, right? Now suppose I'm finding out the column 2, mean, median, anything, right? So over here I'm just going to make this progress equal widget, so that it will tell us that how much seconds it will take in order to execute this particular code. So once I execute this, you'll be able to see that okay, it's just taking 1.01 seconds, right? It's amazing, right? And here is the mean value. Let me just see with respect to other values that I have. Okay, suppose if I say median. Okay, now we are executing with respect to median. Let's see how much time it will take. Okay, it does not. Okay, sorry, the method name I have written in the wrong way. Okay, expression object has no attribute median. It's okay. Let's see some other parameters. Mean, median, drop. So we have various minimum value. Okay, let's check this minimum value. Now here you can see 71. Definitely, like how fast it is happening, right? Now suppose if I want to find out the max value, quickly it is happening very quickly. And let me just see with respect to some other things like mean, and then I'm right. We do this, and you know that we have worked it, right? What we do is that let me just show you.
Like most of these libraries, it's very difficult to install on Windows. Unfortunately, most of them fail.
Hello friends, welcome back to the channel. I'm Sunny Kuswan. Today I'm going to talk about the Vaex high performance Python library, which is 1,000 times faster than the pandas library. Yes, you heard it right, that it is 1,000 times faster than the pandas library. Okay,
The problem with using a virtual machine is that it's another barrier, it feels like. Because then you have to open the virtual machine and then you have to, it takes some time. It's different. I don't like it very much. And I also can't use the two monitors when I have the virtual machine. Maybe it's just a habit thing, but... And then I can't move everything to Linux because then streaming doesn't work.
This episode I'll show you the proof that it is 1,000 times faster than the pandas
I think Linux is bad for streaming.
by applying the Vaex and pandas library on the same dataset. So before that, let's quickly go and get the more details about this Vaex library. So I'm on the pypy.org site, and here you can find that Vaex is a very high performance Python library for lazy out of code data frames. Okay, so it is similar like pandas, and it is having a great capability to visualize and explore the big tabular dataset. And main key point is that it can deal with more than billion rows within a second. Okay, so doesn't it sound crazy that it can deal with billions of records within a second? And another key point of this particular library is that Vaex uses the memory mapping, zero memory copy policy, and lazy computations for the best performance. Okay, so even though it is dealing with the billions of records within a second, there is no memory wastage due to the memory mapping and the zero memory copy policy. So now let's go and see that how to install this Vaex library. So here you can find that simple command is that pip install Vaex. So let's go to our Jupyter notebook and try to install pandas and Vaex, and let's see its performance. So I'm just going to my Jupyter notebook, and here I have already written some code to demonstrate you the performance of this Vaex library and prove that it is 1,000 times faster than the pandas library. Okay, so here we are quickly installing these both libraries, pandas and Vaex. So I have already installed it, so I'll get a message that requirements are already satisfied. Okay, so let me just go and import these packages. Okay, so here I'm importing our Vaex package, and here I'm importing the pandas package. Okay, I'm also importing NumPy package. I'll tell you that why I'm importing it. Okay, so let me just quickly import these packages first, and once I import it, now I have to create one very big data set, so I can apply these both libraries on the data set and see the difference, that what is the performance difference we are getting with these both libraries. So I'm going to create one data set with millions of records. Okay, so here you can see that I have defined the number of rows as 1 million and number of columns as 20, and I'm going to create one dummy data set. Okay, so I'm just going to create one random data frame, and that data frame I'll store in one CSV file, so I'll get a very big data set file, and on that data set file we try to apply these both libraries. Okay, so here I have defined the 1 million rows and 20 columns, and here with the help of pandas I'm creating the dummy data set. Okay, and I said that I'm importing the NumPy, so here you can see that I'm using a NumPy to generate the random numbers, so I can place in this all 1 million record. Okay, so now let me just run it, so it will create the data frame with the 1 million records, and once it created, now I'm going to save these all records in one file, name it like a dataset.csv. So let me just quickly save it. So now it's saving this all 1 million records inside of one file, so it will take some time, so let's wait while it saves the all dataset inside of this dataset.csv file. And once this file is ready, I'll go to my local storage and I'll show you this actual file, what is the content and its size, and then we'll try to load that particular file with the help of pandas and Vaex, and then we'll compare its performance. So now you can see that cell execution is completed, so let me just go back to my local storage, and this is our notebook, and here you can see that this is the dataset file is created. Okay, so if I just right click and open it, so you can see that this is the CSV file, and we have tons of the records. Okay, if I just keep scrolling, and it will go on. Okay, so these are the 1 million records we have just created and stored in this dataset.csv file. So let me just close it and go back to my local storage. Okay, and here you can see that the file size is around 200 MB. Okay, so now let's try to load this 200 MB file with the help of our pandas library and Vaex library, and let's check its performance. Okay, so here we have written a code to load this dataset.csv file with the help of Vaex library. Okay, so here I'm using this percentage time command to record the time it takes for executing this cell. Okay, so let me just try to run it, and let's see that how much time it takes. So I'm going to run it now, so let me just press shift enter, and let's see. Okay, so now it's loading, and let's see that how much time it takes. Okay, so here you can see that it took around 18 milliseconds to load this all the file data. Okay, now let me just go with the pandas and let's see that how much time it takes. Okay, so let me just try to read the same dataset.csv file with the help of pandas. So I'm going to run cell now, and let's see how much time it takes. Okay, so here you can see that it took around 5.14 seconds. Okay, so you have to observe that with Vaex we are able to load this file only within 18 milliseconds. Okay, so if you want to compare that, 1 second is equal to 1000 milliseconds. Okay, so it just loaded this data within the 18 milliseconds, and here you can find that with the pandas library it took the 5.14 seconds. Okay, so you can clearly observe that this Vaex library is 1000 times faster than the pandas Python library. Okay, so this is all about this Vaex library, and I also demonstrated that it is 1000 times faster than the pandas library. So if you are more interested to learn about the Vaex library and how we can perform the different operations like data manipulation with the help of this Vaex library, the way we used to do with the pandas library, then just let me know in the comment box. I'll create one complete video on how to use the Vaex library to manipulate or pre-process our dataset. Okay, so hope you learned something new today. If yes, then please hit the like button, subscribe to this channel to learn more about data science and machine learning. Thank you for watching. Stay safe, stay happy. See you in the next episode. Bye bye.
I think that's the same page that I was. Yeah, here. And so maybe that's the problem. Maybe don't have administrative admin privileges to install here. So I think that's what I'm gonna research now. I'll have to wait this. I wonder if I can. Just gonna close this and then reopen the privileges. Pretty sure it's gonna give me an issue, but hopefully not. So I can move on and start singing. I think after I figure this out, I'm gonna probably start working on building the graphs. And I think I'm gonna use this as well to query or to create different data frames or different. Once it gets time to study how to get different things from the blockchain, I'm gonna probably use this library to get other information. It doesn't seem like there is a lot of information on this. It seems like there's a lot of mistakes for conversions in C++ file. It's converting, but obviously I have no idea what's going on because it's going to involve the source code, and that's the problem. That's the most difficult thing about programming in general. You never know how long something's gonna take, because when you encounter a mistake like this, you uncover all the hidden complexity under the hood of all these libraries, which is enormous. And then there's a chance you get stuck on this, trying to figure out for a very long time. And then at that point, it might not be worth it to even try to do it. And it might be even better to try a different approach. And it's always hard to tell which way to follow. So maybe it's the version of NumPy based on this thing here. So it looks like it's this Vaex core that is the issue, but maybe not. Maybe it's just the first one that was gonna be built and then it broke. Yeah, but looks like some of them worked. Yeah, a lot of them worked. So I guess the issue is on the VX score, VX score. Usually when I have something like this where there isn't a lot of information, the best thing to do is just to break the problem down and search thing by thing, and then it's harder, obviously, because you don't have the answer exactly for what you want. So try to do this as a last resort, because if you can just find the direct answer or something close, then it's a lot better. But if you can't, then you just break the problem several different parts, and then you try to understand how they connect with each other. And then through this process, you learn a lot. Just something that happened a lot with the project, with the Nights and Weekends project so far. And then that's the reason why it takes a lot more time to do it, because you go in these tangents and then try to learn all of the stuff so you can go back and figure out what was wrong with your stuff. And the issue is that it takes a lot of time, but on the positive side, after you search and you go through this process, which is painful, then you grow and you become better. And I think you learn a lot more by doing this, obviously, than by watching videos. But a good mix of both, I think, is the best way, probably. So I'm gonna try to install this stuff here. And that's weird. I was typing it incorrectly. So the issue is not this. Whatever this is. Oh, this guy is really good as well. I was watching some videos about Python from him. So it seems like the issue is the Vaex score module, Vaex score. Let me try to install it again now, see if it works. It's probably gonna fail again. I don't see why it wouldn't. But it's worth trying. Maybe it was failing because I didn't have the other package. And the other package is necessary, I don't know.
Hello friends, it's Raju. Decided watching my YouTube channel Pyguru. Friends, in today's tutorial, we are going to learn how can install wheel files in Python. Okay, see, there are certain packages that we cannot directly install from pip. Okay, if you try installing them, you may get some error. And there's an alternate way to install those packages in Python, that is using the wheel file of that package. Okay, now a wheel file is simply a Windows binary installation package. You can think it as .exe file. Okay, by which we can install the specific package in Python. Okay, so see here, currently I need a Python package whose name is PyAudio, and it is generally used to work with audio in Python. Okay, so if I try installing it from cmd, let me open command from here and try installing it by pip install PyAudio. You will see I'll get an error. So let it get executed and selecting PyAudio using PyAudio. Okay, and here I will make an error and which says that Microsoft Visual C++ 14.0 is required to install this package. Okay, now what you do in that case, simply just a workaround. What we have to do, we have to download the V file of this package, of this PyAudio package. Okay, in my case this is PyAudio, in your case it may be any file, any of Python package. Okay, so how can we download the V file of that package? Simply you have to visit a website whose link is ifd.uci.edu. Okay, I will give this link in the video description, so you can go visit from there. Let's ifd.uci.edu. Let me search it again. Okay, and okay, so ifd.uci.edu Python. Okay, so from here select the first link, Python extension package for Windows by Christoph Golk. Okay, so you have to visit this website. Now see, this is an unofficial website, and this person Christoph Golk, thanks to him, keeps and you can say that all the updated version, all the updated wheel files of Python packages here. Okay, so you can simply download this Python packages. What you have to do, simply you have to search your wheel file. So I have to download PyAudio, so I will simply search PyAudio from here, and let's see if it's available. So how can you do that? Simply you have to scroll down, and we, okay, it's in alphabetical order, so we have to go down until we find PyAudio for us. Okay, let me scroll here. D E F G H, yep, MNOP. Okay, so let's search PyAudio. Oh, and pandas. Okay, so let's scroll some down. Oh, cleaner, Postgres adapter, pulp, PyEarth, PyFC, PyLMDB, Py2ac, PyLMB, PyMF. Okay, so I think we are near to it. Okay, so see here we have a PyAudio wheel files. Okay, so you have to download this wheel file according to your Python version. See, I'm a Python 3.8.1 user. So if your system is of and
Hello and welcome to another video. In this one, we're going to talk about wheels and what they mean for Python. And let's jump into it. Okay, so the name wheel seems a little bit weird, and admittedly, it's kind of a long-running joke that even I don't really understand. The nature of this joke comes from calling PyPI, which is the Python package index, it has the nickname the cheese shop. And a wheel is like a wheel of cheese from the cheese shop? I don't know. I'm not going to even try to understand what it means there. But I'm going to talk to you about what wheels are and what the file name is special about, what they're structured inside, how you can go about installing them, and yeah, I think we'll cover that. Now, before wheels, there were two ways to install packages. There was from a source distribution, which is either a zip file or a tar.gz or any other compressed archive, and you would install from source, meaning anything you had to build, you would have to build it yourself when installing. There was a pre-built package that was called an egg. Eggs are actually very similar to wheels in a bunch of ways, but eggs fell out of fashion because they involved weird Python path hackery and didn't really set up stuff in a super well-defined way on disk, and wheels provided a much more stable and reasonable way to do that. The current modern approach to packaging, you typically can install pretty much everything from a wheel, and rarely need to use a source distribution. I say rarely, there are actually quite a few examples where you would use a source distribution. We're not going to go over that today. But what a wheel represents is it's a pre-built package that's installable just by unzipping the archive and not running any code, which can be really important for both performance, because running code on installation, building stuff from source takes a long time. That can slow your stuff down. But it's also useful for security. So if you're installing packages from wheels, you tend to not be running arbitrary code from the internet. You're really just unzipping files into the destination state. Now, I've downloaded a bunch of wheels ahead of time to kind of show you how they're named. I happen to pick a bunch of different ones, hopefully highlight some various things about them. And we'll also go over the structure of what's inside of these wheels. I mentioned earlier that source distributions can be zips or tarballs or any sort of compression state. Wheels are always have the file extension WHL, and they're always zips. So these are just fancy zip files that have a different extension and a very particular naming convention. Now, the naming convention is split up into components. Each component is separated by a dash, and the first component is the name. So you can see this first wheel is the AST pretty wheel. Note that if there are dashes in the name, they get normalized to underscores. So you can see your Babby parameters is actually Babby dash parameters according to pip, but you're always going to see an underscore in place.
Yeah, I think I've seen this type of file many times when I was doing some stuff with both Solana and Linux and other stuff like that. So it's just a different type of file, apparently.
Those dashes there. The second component is the version number. So this is the version number of whatever library. So in this case, I have AST equals 1.
So I think it's probably the reason why I'm having issues is the same reason why I have issues in the past with Windows, with stuff like this. It's more to do probably with the way that the operational system handles these things, and it has to do with C++ stuff as well, probably. But I'm not really sure what the difference is between Windows and Linux when it comes to these things. But yeah, probably works fine on Linux, this Vaex core. But I don't want to use the virtual machine. Maybe I'll end up using that, but I think I'm gonna spend a lot of time trying to figure out how to do this without using the virtual machine. And if I can't, I probably gonna think about a different way, honestly, to display the data frames faster.
7.0, you can see the version numbers for some of these other ones. And then the last part of the wheel are the last 3 components, and these are usually kept together and referred to as a platform triplet. Other people call them other things. That's why I refer to them as.
Because then the issue would be that I would have to move the whole project into the virtual machine as well, and then increases the storage a lot, and it creates a lot of different problems, and it's gonna take a lot of time. So yeah, I really don't want to do that. Just wanna
first component of this is the pipe.
Focus as much as I can in the stuff that I'm more interested about first, rather than this side stuff. And what I'm most interested about is the analyzing the blockchain data and searching the blockchain data. Yeah, but I don't think I'm gonna be able to get around this, because it is really important, because it's inevitably a lot of data that I'm gonna have to analyze. So probably later on I'm gonna have to figure out anyway.
Python versions it targets, and there's a couple of different things you'll see here. In this case, this is pi2.py3, and note that a dot in any of these 3 platform components means kind of an OR relationship. So this supports both pi2.any and pi3.any, and this dot is kind of like a curly expansion of Bash, where it can be any number of those things. And sometimes these dots get a little bit ridiculous. Like you can see here, this one is manulinux 2.5 x86 64, or manulinux 1 x86 64, or manulinux 2 17 x86 64, or manulinux 2014 x86 64. So this third component can be any of those things. I talked about the first component is the Python version that targets. You'll see py for pure Python things. This means it doesn't have any binary artifacts, doesn't have any C extensions, that sort of thing. So you'll see py for that. And typically you'll see either pi2, you'll see pi3, and very rarely, occasionally, you will see something like this, where it has a specific minimum version number. And note that this platform tag, this language version tag, implies any version after that. So pi3.6 is going to represent, is going to be installable on 3.7, 3.8, 3.9, 3.10. In the same way that pi3 is installable on any Python 3 version. Now there is a bit of a asterisk there. Pip does adhere to major versions here, so if you saw just pi2 here, that wheel would not be compatible with Python 3. In the same way, by seeing pi3 here, it would not be. We don't actually know because Python 4 doesn't exist, but presumably if it followed the same pattern that Python 2. At least C Python allows to have any binary relevant in Python 4 and then version numbers. At class here, there's also platform, kind of the simplest case for each of these files as well. Actually, let's just unzip that. But the classifiers, differential checksums, slash wheels that have these are going to be that disk info directory, that wheel metadata we talked about. In the .h directory, it's actually kind of weird. I kind of expected it to just end up in the top level, but I guess it doesn't necessarily work the way I expected. But yeah, that greenlit.h ends up in the special include directory, and again, the installer tool manages this directory especially. Beyond that, all this ended up in site packages. We have site packages, and so you can see the greenlit directory as well as the greenlit disk info. And the last thing is scripts. US CLI happens to have one of these.
Maybe what I can do is install the wheels directly. No, I don't understand this error really well. Which use PAP 417 cannot be installed directly. So is it saying that this is necessary to install? I don't understand this. This message. I think what it's saying is that you can't download the files for this thing here, and the files are the wheels, like the guy explained. Not that extension. And they use this thing here, whatever this is. But then I'm not sure what cannot be installed directly because I didn't install this thing here. So I think the time is over. I'm gonna be done by now. Probably. I'm not sure how long it's gonna take to do the rest of the stuff. If it is fast, then I'm probably gonna stream this week to finish this, to style the page. Maybe, I'm not sure. I will think about it. Yeah, but I'll probably, after I'm done with being able to display something at least here, if I'm able to do it before next week, then I think I'm gonna study this stuff, this Vaex stuff, and try to create the graphs on string, probably. Yeah. And then if it takes more than 1 week to figure out how to display the data here, then I think I'm just gonna continue to study this thing here. Yeah, so see you then.